We are in Chapter 1, Introduction to Statistics. This is Section 1.1, Statistical and Critical Thinking. Statistics is the science of collecting, organizing, summarizing, and analyzing information or data to draw a conclusion. It also provides a measure of confidence to any conclusion. Statistics is very useful. You guys will see that in sports. You'll see that on the news, world reports, the census. So much statistics are out there. There's a big difference between normal math classes and statistics. So normally in a math class like algebra or calculus, you'll be given a problem and you solve it. You can check in the back of the book to see if that answer is correct. Whereas statistics, you collect data, you have a study, you're trying to draw a conclusion from that, and you place a level of confidence on the study. And it's a way different approach, a lot more words, a lot more analyzing, a lot more critical thinking. We have a bunch of definitions down here that we need to know. So we have population is an entire group that's being studied. An individual is a person or an object that is a member of the population being studied. We have a sample. This is a subset of the population being studied. Census is an attempt to collect all data from the whole population. Data is the collection of observations. Datum is a single data value. And sampling methods is a procedure used to decide which individuals will be included in the sample and how they're going to be picked from the sample or from the population. Example says fill in the blanks. The blank is the collection of all cars owned by all faculty. And the second one says and blank is any subset of the population, say cars owned by the math department. So the first one is everybody, so that's our population. The second one is a subset, and so this is going to be our sample. The process involved in a statistical study is summarized below. It pretty much outlines how we're going to be running our whole entire semester. So we're going to prepare what does the data represent, the goal of the study, the source of the data, sampling methods. Then we're going to analyze. We might graph, we're going to explore data, look and see if there's outliers, summarize the data, how is the data distributed, applying statistical methods, and then conclusion, we'll talk about significance. So this is pretty much our semester summarized in a table. We have different kinds of sampling responses that we could have. And so the first one on here is voluntary response. And this is self-selected sample, a sample in which the respondents themselves decide whether or not to be included. We have statistical and practical significance. So statistical significance is when the result is very unlikely to occur by chance, 5% or less. And then we have practical significance, are the differences between samples being big enough to have real meaning. So we have some pitfalls to analyzing data. First one on here we're definitely going to give a star to. That says correlation does not imply causation. Just because there's some kind of relationship between two things does not mean one will cause the other one to happen. Sample data could be reported, not measured, meaning that I asked you guys to report your GPAs. You might not be honest with me. Loaded questions or the order of questions, we have non-response. Certain people don't respond to get enough data or from the entire population. Percentages is another big mistake. So there's 4 problems on here on percents. And the first one says 6% of 1,200. So we need to rewrite percentages to be decimals before we can actually use our calculator to solve them. So rewriting this, we got to rewrite this as 0.06 of means times 1,200. And this works out to being 72. Converting 0.347 to a percent, we're going to move our decimal place 2 times to the right, and we get 34.7%. Converting 2/5 to a percent, we can divide our denominator into our numerator, and when we do this, we get 0.4, and moving our decimal place 2 times to the right, we get 40%. Converting a percent to a decimal, we're going to move our decimal place 2 times to the left, and we get 0.892. Next example on here says determine what is wrong with the example. The first one says, in the USA Today online poll, 951 internet users chose to respond, and 57% of them said that they preferred drinking bottled water instead of tap water. So the issue here is that people were choosing to respond, and this is voluntary response. And so since they are choosing to respond, it's not a very good sample that we're collecting, and it doesn't accurately represent the population. The next one says, in recent years, there has been a strong correlation between per capita consumption of sour cream and the number of motorcycle riders killed in non-collision accidents. Therefore, consumption of sour cream causes motorcycle fatalities, and we cannot use the word causes. We can never say that. And this is because association, just because we find some kind of relationship between two things, does not imply causation. The next example says the USA Today reported results on which 1,458 men and 1,543 women were asked this: in a typical week, how often can you kick back and relax? Part A says among the women, 19% responded rarely, if ever. What is the exact value of this 19% of women surveyed? Is the result the actual number? Explain. So 19% would be rewritten as 0.19. And since we're just talking about women, there is 1,543 women. Multiplying this out, we get 293.17 women, which does not make sense. So we are going to round this to just 293 women. The next one says among the men who responded, 219 responded with rare if ever. What is the percentage of men who responded with rare if ever? So men that responded was 219 out of a total of 1,458. So 219 over 1,458 is going to equal 0.15. And this is going to go ahead and be rewritten as a percent, and this is 15%. 1.2 is types of data. A lot of vocab in here too. So we have parameter and statistic. So parameter is a numerical measurement describing some characteristic of the population, whereas a statistic is the same thing but talking about the sample. So it says, example, it says, suppose 67.3% of students at a college are taking at least one math course. This value represents A because blank. And then the next one says, suppose we have a sample of 100 students and 70.1% have at least one mathematics course. This value represents blank because of blank. So the first one here is talking about all the students. And the second one is talking about the 100 students, so it's a sample. So the first one that we're dealing with is a parameter. And this is because it's talking about the population. This is the population of students. And the second one is a statistic. And that is because this is a sample. So this is our sample data here. Next thing we have is qualitative and quantitative data. So qualitative or categorical data allow for classification of individuals based on some characteristic, such as hair color, ethnicity, type of car, day of the week. Quantitative data provides numerical measurements of individuals: weight, height, GPA, temp. So example says classify the variables as qualitative or quantitative. So the first one on here is marital status, and this is single, divorced, widowed, married, and this is a categorical data. So this is qualitative. The next one on here is the number of hours a student sleeps per day. That's a number value, so this is quantitative. The next one says the cost of a new car, which again is numerical. So that is quantitative. The next one says the number on a soccer player's jersey, and we are going to assume that it's just like a rec team. These numbers have nothing to do with anything about their position or anything along those lines. And because of that, we'll say this is qualitative. Next vocab words that we have on here are discrete and continuous. Discrete variables are quantitative variables that have a finite or countable number of possible values. Days in the week, there's 7. Number of students in class, we can count you guys. Pages in a book, we can figure out how many pages there are. Versus continuous data, this is also quantitative data, but it has an infinite, not countable number of possible values. These are usually measurements. And with measurements such as time, temp, weight, and height, for temperature, if you were to say it's exactly 72 degrees right now, that's not exactly true because that's just as far as we see it. It's probably 72 point and keeps going on. Likewise, with your weight, if you are 200 pounds, you're probably not exactly 200, and your height is probably not exactly 5'6". So it continues on. Times is the same way. There's milliseconds, and same with heights. There's inches. You can even go smaller in centimeters, and then millimeters, and then it keeps going down even smaller. So next example says to determine whether the variable is discrete or continuous. So the number of apps you have on your phone is discrete. You can count those. The length of a baseball game, because we are measuring something and time is continuous. Temperature on any randomly selected day. Again, temperature is a measurement, so this is continuous also. Home runs hit by a baseball player is discrete. Life expectancy of a person, this would be by age. And age, again, you're not exactly 20 years old. You have months and days and minutes and seconds and so forth. And this is continuous. Next set of vocab words we have, and these are ones that are more of a struggle for students, is the level of measurement of a variable. So first thing is I'm going to work my way down with these. So the first one is nominal. It says if the value of a variable, name, label, or category, in addition, the naming scheme does not allow for the values of the variable to be arranged in any random order. Everything has a level measurement of nominal. So we're just going to take that as a given. That is something that they all have. Next thing, ordinal is going to be if it has all those same qualities. However, it can be arranged or ranked in a certain order. Okay, interval is if the variable has everything that the ordinal level has. However, the differences, and differences mean in math, subtracting, of the values has a meaning. So you can subtract them and it has a meaning. Ratio is going to be if the variable has the properties of the interval level of measurement. So the differences have some kind of meaning. And there's going to be a natural zero starting point. And then the ratios, and ratios is going to be division. And those have a meaning also. So you're able to divide your numbers and that has a meaning to it. So on the next page, there's an example. The example says determine the level of measurement of each variable. So A is birth year. And birth year is something that we can, everything starts as nominal. You can arrange them in order and it makes sense. And if I were to say that someone was born in year 2002 and someone was born in year 2000, we could subtract those and that makes sense. So that means that it is also interval, but dividing those wouldn't make sense. So we would stop at interval. So this has an interval measurement, level of measurement. Marital status, this is married, single, divorced, widowed. Everything starts off as nominal. Can you put those in any kind of order and it makes sense? No, we have no order. You see those different orders listed most of the time on different applications and things along those lines. So that would be, it says nominal. Level of measurement. Letter grades of all students in the statistics class. So letter grades would be like A, B, C, D, and F. And so everything starts off as nominal. Ordinal, can you put those in order and it makes sense? Yes, you can put A's, B's, C's, D's, and F's. So from the highest letter grade to the lowest or vice versa. Could you subtract them and it makes sense? What's a D minus an A? That doesn't make any sense. So that means it's not going to be interval. So this would be ordinal. Heights of K through 12 students. So for this one, we have everything starts out as nominal. Ordinal, you can put the heights of these students, yes, in order and it makes sense from smallest to largest, largest to smallest, or any of those ways. Interval, let's just make an easy example and say a student is 6 feet tall and another student is 3 feet tall. So if I were to subtract those, I would have 6 minus 3, so that is a 3-foot difference, and that makes sense. Now could I divide them? So I get 6 divided by 3, I get 2. Well, what does that tell me? Does that 2 tell me anything? Yes, it tells me that the 6-foot person is twice as tall as the 3-foot person. So this would be an example of ratio. So again, you're going to go through these and you're going to just ask yourself, everything starts out as nominal. Then ask yourself, can I put them in order and it makes sense? Next thing, can I subtract those values and it makes sense? Next one, can I divide those values and it makes sense? This is section 1.3, collecting sample data. First thing is we have a bunch more vocab words that we need to know. We have response variable, which is a quantity that we're asking a question about. We have a placebo, which is a harmless medication like a sugar pill that looks and tastes and smells like the experimental medication. We have a gold standard, which is randomization with placebo and treatment groups. Experiment is a treatment is applied and then the effects are observed. The individuals in the experiment are also called experimental units, and they're often called subjects when they're people. Treatment is the factor, an explanatory variable, an independent variable manipulated by the experiment. We have a control group. This is the group of subjects or conditions that is matched as closely as possible to the experimental group, but is not exposed to any experimental treatments. This is used to compare. We have a placebo effect. This is an individual subject believes they receive a treatment. Observational study is where you observe and measure specific characteristics, but we do not attempt to modify the individuals being studied. So definitely these are all words that we need to know. You are asked to compare a lot of times an observational study to an experiment. So an observational study is where you sit and watch and observe, and then an experiment is where you're going to give some kind of experimental unit to them and some kind of treatment to that group. So the first thing that we have on here is an example. The example says, determine whether this study is an experiment or an observational study, and then look for a major problem within that study. So the next thing on here is A, and it says, in a survey conducted by USA Today, 1,465 internet users chose to respond to the question posted on the USA Today electronic edition. Is news online as satisfying as print and TV news? 52% responded yes. So this is an observational study. What is the problem with this? They chose to respond. So that's that voluntary response that we saw earlier. So this is voluntary response. Part B says an independent researcher tests the effects of the Atkins weight loss program by randomly selecting 1,000 subjects using that program. Each of the subjects was called to report their weight before the diet and after the diet. So this is an experiment The treatment that they're dealing with is an Atkins diet, which is a high-fat, high-protein diet. So this is going to be an experiment. I know it doesn't ask for it, but the treatment is the Atkins diet. And what is wrong with this? It is self-reported data. And so they could be lying or not being honest about their weight before or after. Next thing we have is blinding. This is the subject does not know if they received the treatment or a placebo. So most experiments are going to be blinding. Double blinding now is going to be where neither the experimental unit nor the researcher in contact with the experimental unit knows what treatment the experimental unit is receiving. Sometimes our body language portrays something along the lines of if they know or if they don't know. So a lot of times the researcher or the nurse that's giving the medication will not know. Replication is the repetition of an experiment on more than one individual. Randomization is used when individuals are assigned to different groups through a process of random selection. And then we have our first type of sampling. This is called simple random sampling. You can abbreviate it all throughout the course as SRS. It is a subset of N individuals, a sample chosen from a larger set, capital N, our population, and each individual of the subset has an equal probability of being chosen. So just people are randomly selected for a group. Example on here says, in an experiment in which blood pressure medication is tested, Group A is given blood pressure medication. Group B is given a placebo pill. The two groups do not know which medication that they were given. However, the researchers do know. Questions are, what is the treatment? What is the control group? And what kind of blinding experiment is this? So the treatment that we have is blood pressure medication. And that is our treatment. Our control group is the group that's given the placebo pill, and that would be Group B, or the placebo group. And this is, it says that the researchers do know, but the experimental unit does not. So this is blinding or single blinding, sometimes it's written as. So this is a single blinding experiment. Again, it can be also just written as blinding. So single blinding. Next example says the plant ginkgo biloba has been used in traditional medicines for thousands of years. Doctors and researchers want to figure out if it can be used to safely treat symptoms of dementia caused by Alzheimer's disease or multiple strokes. In this placebo-controlled single blinding experiment, 309 subjects were either given daily ginkgo extract or a placebo and were followed for the next 52 weeks. So first question here says, what does it mean for the experiment to be placebo-controlled? That means that some subjects are going to be given a placebo. So some subjects given a placebo. B says, what does it mean for the experiment to be single-blinded? This is going to be where the researchers know. What's given, but subjects do not. What is the population for which this study applies, and what is the sample? So the population is going to be adults with dementia. This is our population. And again, you guys can fill in more. This is also, it says it's, and the wording is up here. It is dementia caused by Alzheimer's disease or multiple strokes. If you wanted to, you can write that whole part in, but it is adults with dementia. The sample that we have, the sample size that we have is a total of 309 subjects. So this is going to be 309 adults with dementia. And this is our sample. The next one says, what are the treatments? So the treatments were they received a daily ginkgo biloba extract, and they received this extract for 52 weeks, so for a year, for 52 weeks. What is the response variable, and is it quantitative or qualitative? So they're looking for, what this question is about treating symptoms of dementia. So treating symptoms of dementia. And is this qualitative or quantitative? This is probably going to be qualitative. They usually ask questions and see what they can remember in a story or something along those lines. Next thing we have is where we get into the different types of samples that we have. So we saw simple random sample earlier. We have stratified sample, which is where you separate the population to non-overlapping or mutual exclusive groups called strata, and then obtain a simple random sample from each of the stratums. The individuals in each stratum should be homogeneous or similar in some way. The benefits of stratified sampling over simple random sampling are that they may allow for fewer individuals to be surveyed, yet still obtaining the same or more information. An advantage of stratified sampling is determine characteristics within each stratum. So you can split people, usually it's people that we're studying, our subjects, into groups based upon maybe their political affiliation or by their gender or by their GPAs or by their heights. There's a lot of different ways to split people into groups, and where all those groups have nothing, they all have something in common, but not with the other group. If you're talking about height and you were to say from 5 feet to 5 feet 5 inches, all those people in that group would have that height range. So we have an example on the next page. It says ASB at a local high school wants to determine a student's opinion on recent assembly. They divide the school into groups based upon grade level. The school has 572 freshmen, 523 sophomores, 491 juniors, and 437 seniors. The ASB director wants to survey 100 students with the number of individuals selected from each stratum weighing by population size. What are the different stratums in this survey? So the different groups that we would put students in for this, and those are non-overlapping, so you don't have a freshman and a junior at the same time. So we have freshmen all together, we have sophomores all together, we have juniors all together, and then we have seniors all together. So there's 4 different stratums that we have in this survey. Next kind of sampling that we have is systematic sample. And a systematic sample is obtained by selecting every kth individual from a population. The first individual selected corresponds to a random number between 1 and k. The benefit of systematic sampling is that it doesn't require a frame, so you don't need to have a list of individuals in a population. The example here says a local hardware store decides to survey every 5th person who walks in the store. The owner randomly selects a number between 1 and 5, let's say 3, to determine which customers they will survey. So they're going to survey the 3rd person as they leave the store and ask them how their shopping experience was. And then they're going to, every 5th person from here. So I'm going to add 5 to this value. So the next person that we're going to survey is going to be the 8th person that leaves the store. Then the next 5th person would be the 13th person that leaves the store, and then adding 5 again. The next one's going to be the 18th person that leaves the store, adding 5 again. The 23rd person that leaves the store. And this process, put some dots in here, continues on until that owner has collected enough data, or until maybe the store closed. Maybe they'll start this up again the next day. Next type of sampling that we have is called cluster sampling. Cluster sampling and stratified sampling get confused. So cluster sampling is where you divide the population into sections or clusters. It does not matter. You can just split the class in half. It has nothing to do with anybody having the same kind of characteristic like we saw earlier with freshmen, sophomore, juniors, and seniors. This would be just cutting the class into 4 pieces. So saying we're just going to divide up students into 4 different groups. It doesn't matter what grade level they are. It doesn't matter anything. So these are clusters. Then randomly selecting some clusters and choosing all members from those select clusters. The next type of sampling we have here is convenient sampling. It says in a sample in which individuals are easily obtained, self-selected, and it is not based on randomness. For example, phone-in polling, internet surveys, solicitors at a store. These results are unreliable. This is not a good way to collect your data. Multi-stage sampling is using a variety of these different methods together. To determine the sample size is key in the overall statistical process. Researchers need to know how many individuals they need to survey in order to make a conclusion about a population from its finding. Realistically, the main determining factors of a sample size is going to be determined by the amount of time and money that the researcher company has. We will spend some time figuring out sample size later on in the semester. The next example says assume that the population consists of all students currently in your statistics class. Describe how to obtain a sample of 6 students so that the result is a sample of a given type. So we will go ahead and work on this one together in class. The next example says determine the type of sampling that is used. Part A, the author collects sample data by randomly selecting 5 books from each of the categories of science, fiction, and history. The number of pages in the books were then identified. So they split this into types of books into different categories: science, fiction, and history. So since they put these into groups, and these are mutually exclusive or non-overlapping groups, and then it says the number of pages of those books were then identified. And it says that they collected data, they randomly selected 5 books from each of these categories. So this is an example of stratified sampling. B says, during the last presidential election, CNN conducted an exit poll in which specific polling stations were randomly selected and all voters were surveyed as they left the premises. So again, this is broken up into groups. These groups, though, are polling stations, and they didn't just poll and survey a few from each of these stations. They got all of them. Versus up here, it was only 5 books that they were sampling from. So since this is everybody from the whole entire polling station, this is considered a cluster sampling method. The next thing that we have on here is complete randomized design. Each experiment unit is randomly assigned to a treatment. We have a matched pairs design. This is an experiment design in which experimental units are paired up. The pairs are selected so that they're related in some way. You can be matched up against a twin or before and after. We have randomized block design. This is used when experimental units are divided into homogeneous groups called blocks. Within each block, the experimental units are randomly assigned to a treatment. Then we have different errors. So we have non-sampling errors result from under coverage, non-response bias, response bias, or data entry errors. We have sampling errors result from using a sample to estimate information about population. This type of error occurs because a sample gives incomplete information about a population. And then we have non-random sampling error is the result of using a sampling method that is not random, such as the use of a convenient sample or a voluntary response sample.